Hello, today my group and I will be discussing the knee drive that comes out of a three-point stance. My name is Emily and I will be doing the analysis portion of this movement. Starting out by looking at the first phase, this is also known as set position. You can see in the image right here that this man is doing the set position. Starting out by discussing the leg position, there should be a front foot. This will be the weight-bearing leg in this position. It should be a little bit ways behind where the arm will be touching the ground. The second leg should be in the stance position as well, a little bit behind the first foot. The tibiofemoral, acetabulofemoral, and talocruciate joint are all in flexion on this weight-bearing leg. There should be no weight bearing happening with the arm. That is simply for stability and balance in this position. With the arm touching the ground, the elbow is extended, the shoulder is flexed. There is also adduction in the fingers that are touching the ground, as well as extension in the thumb and wrist with ulnar deviation. The opposite arm should be up behind the back in this position. Continuing on with the set position, the muscles are working isometrically here. This stance position is staying the same. There is no actual movement of the body happening just yet. So with holding the static position, this will be isometric contraction. The body is holding itself up via the calf and quadriceps muscle, along with the assistance of the arm. The soleus, gastrocnemius, rectus femoris, vastus lateralis, vastus intermedius, and vastus medialis will all be muscles used in this position. With moving out of this position, then it will become a concentric contraction because the muscles will be short and tense, and they'll be prepared to push off and use power for the body to accelerate and move forward. Moving on to phase 2, this will be the first knee drive happening. This is also the beginning of the acceleration. Movements are happening in the sagittal plane, and it's important that these movements are happening in the sagittal plane because if any other movements are happening outside of these, such as the top half of the body twisting in the transverse plane, it can throw off all the other movements. So there should be the parallel movements happening in the sagittal plane there. So with looking at the back leg, I will actually just show these photos right here. You can see in the first image and the second, 90 degrees is the angle that is happening at both the ankle and the knee. At the ankle, that is also called dorsiflexion there. So those two should be flexed. The hip is flexed as well, and there also is a 90-degree angle between, you can see where my mouse is, the body and the leg right there. But instead, with looking at the other leg, that angle between the hip and the leg is a little bit over 100 degrees. It's about 104 there. The leg should extend and create a straight line with the back and the head as well for optimal movement through this. Going back real quick. So on the left side of the body, the ankle, the knee, and the hip are in extension while the shoulder and elbow are in flexion. And then the right side of the body where there is ankle, knee, and hip flexion happening there. So again, the talocruciate and tibiofemoral joints are the two that create the 90 degrees with the acetabulofemoral joint of the other leg forming over 100-degree angle joint. Over 100-degree angle. Not joint, sorry. So moving on, or still on the first knee drive, looking at the rear leg, this will be an eccentric muscle contraction because, again, those muscles are being elongated in this part of the stance. The semitendinosus and biceps femoris will allow for this extension of the hip joint, along with the gastrocnemius, vastus intermedius, medialis, and lateralis to extend the knee. The gastrocnemius and soleus will allow for the plantar flexion of that back leg at the ankle to happen. So both plantar flexion is happening in one ankle and dorsiflexion happening in the other. Two opposite types of angles here happening on the opposite sides of the body. The excitation will cease in the back leg and push off will happen so that the body can move and go into the next knee drive. With looking at the front leg, which is the leg that will be in flexion and will be driving upwards, this is an isometric hold happening in the leg here. The gracilis allows for flexion of the knee and the hip joint, with the iliopsoas allowing flexion at the hip. Dorsiflexion happens at this ankle due to the tibialis anterior and extensor digitorum longus. Still looking at the second phase or the first knee drive here, any ligaments that play a role. There's the anterior talofibular ligament, and this is aiding in the absorption of the foot when it makes contact with the ground. So this is going to be taking place in both the second and the third phase. So at any point when the foot is coming in contact with the ground, that ligament will play a role. The anterior and posterior taliotibial ligaments at the ankle will limit the dorsiflexion and plantar flexion happening in those as well. Then there are also the knee ligaments. We have the anterior cruciate ligament, the medial collateral ligament, the lateral collateral ligament, and the posterior cruciate ligament. These all resist extension of the knee joint for the knee that will be driven up. The pubofemoral, ischiofemoral, and iliofemoral ligaments will all prevent excess extension of the hip joint during this phase. Moving on to phase 3, this is the second knee drive that is occurring. Movements are still occurring in the sagittal plane. So all of the movements that are happening are just switching over to the other side. So it's just opposite, moving from one side to the other. So the other leg that is now driving up, the opposite arm will come swinging back, and the other leg will replace it for that knee drive. All the same angles should be happening in the second position as well. Again, 90 degrees at the knee and the ankle, as well as at the hip. With the second hip, though, that's the over 100-degree angle that is happening there. Again, the back leg should extend to make a straight line with the back and the head for optimal movement through this. Muscles in this phase, in this third phase, will be the same as the second phase, but just opposite according to the parts of the body. I will play this video clip here. There's the first phase, driving up the knee into the second phase, driving up the other knee into the third phase there. Looking at ground reaction force, this will begin in the anterior portion of the foot that is first pushing off the body. It's important that this ground reaction force is happening in the front part of the foot, more specifically the ball of the foot rolling over into the toes so that the body can push off. This force will act then through the foot up into the leg, extending the leg, and the body will accelerate / move forward. The next ground reaction force is going to happen, but on the opposite side of the body. It's going to occur in the same way, though, on the ball of that foot rolling over into the toes, hitting through the foot, up, extending the leg, and pushing the body forward for movement to happen.